Now let's look at some where the line of reflection is not horizontal or vertical. So number 6, we're going to reflect across the lines y equals x and y equals negative x. So these do actually have specific patterns that we can follow, but let's look at what happens here. Draw the line of reflection first here. Right, so y equals x would have an intercept of 0 and a slope of 1, so just the one diagonal across the way there. Then graph my line segment. So a is 2, 3. B is negative 4, 5. So let's think about this the way we thought about the other ones to start here. So I would go perpendicular would just be a slope of negative 1, and I'd go the same distance from the line as this one was. So A is like a half of this away, so A prime would be just straight across on the other side right here, and that's at 3, 2. And then B, if I'm going perpendicular across, would be this way. So it's going to end up over here at 5, negative 4. Right, and if you wanted to verify, like if this were on paper, you could fold it along that line, and those things should match up. So if you look at what happened to the coordinates here, what happened is that the x and the y switched places, which should make sense. If y is equal to x, that means x is y. So you'd replace y with x and vice versa. So xy just goes to y, x. So that means that the x and y coordinates switch, or are reversed. Now let's look at number 7, where we are reflecting across the line y equals negative x. So it's going to be same idea, intercept 0, but this time slope is negative 1, so it's going the opposite direction. So let's get our segment AB on here again. So going across this one, we can do kind of like we did before, where we count perpendicular diagonally this way, or you could look at like the path. So here to here gets you to A, so if I were to reflect that, go this way, and then this way to get there. So A prime is over here, and just straight across, or you could have, if this were on paper, you could have folded this in half. B prime ends up over here, so we've got this segment. And if we were to write the coordinates, so A prime is now at negative 3, negative 2, and B prime is at negative 5, positive 4. So if we look at what happened there, yes, my x and y coordinates traded places, but they also changed signs. So that changed signs, that one changed signs, and they switched places as well. So if you're reflecting over y equals negative x, then what happens to your coordinates is they're going to switch position and change sign. So xy will become negative y, negative x. So when we're reflecting over y equals negative x, again, they switch places, x and y, and we change the signs. So let's look at an example here. So we need to graph our triangle DEF and its image under the reflection across the line y equals x. And let's graph triangle DEF. So we got negative 3, 2 is D, and we've got E is negative 1, 3, and F is 3, and negative 1. So this one actually does go across the line of reflection, which means when we reflect it, it's going to overlap a little. All right, so we could count from the line, or if I remember my rule, the coordinates of the image points should just be switching the x and y here. So D prime should be 2, negative 3, E prime should be 3, negative 1, and F prime should be negative 1, 3. So let's graph that and see if it looks right. So we got 2, negative 3, E prime is 3, negative 1, interesting, and F prime is negative 1, 3. So that one actually did end up looking pretty interesting there, but that does seem to look right, so that's what that would look like. All right, let's look at a composition for our last one. So it says graph triangle ABC and its image after a glide reflection. So glide reflection is basically just a translation and a reflection. So let's graph ABC. So we've got A is negative 1, 4, B is 2, negative 1, and C is 4, 3. So now that we've got triangle ABC here, we are going to translate it first. You generally do want to do the transformations in the order that they say them, because it's not always going to give you the same thing if you switch the order. So let's first translate this negative 3 and plus 1. So that would be left 3 and up 1, or we can do that by subtracting 3 from the x value and adding 1 to the y value. So A prime would be negative 4, 5. And again, we can do that as 3 left, 1, 2, 3, and 1 up, A prime ends up right there. And really we're looking for the final image after both of those, but it's often helpful to do the middle one, and on your homework, if you leave the middle one there and then graph the final one, it is fine, it still counts as right. So you can have three shapes, the pre-image, the one after the first transformation, and then the final one, and it still will count that as correct as long as you've done it correctly. So then B prime, so again we're moving this 3 left and 1 up, or we can subtract 3 from 2, and that would give us -1, and adding 1 to that one gives us 0. Right there, -1, 0 is where we ended up. Then last we've got C prime, so subtract 3 from 4 is 1, add that 1 to 3 is 4, so 1, 4 is where C prime is. So that is where our middle step is. And then last thing we need to do is reflect it over the line y equals -x. So reflecting this green one, the one after the translation, over this line. And for the diagonal reflections, if we remember the rule, that might be easier than counting across, but you can count across if you're pretty confident in how you can do that. And we've done a second transformation, so we're actually going to call this a double prime, so we know it's after 2 transformations. We're reflecting across the line y equals -x. Remember, that's where x and y switch places and change signs. So this is going to become -5, +4. B double prime is going to become 0, because that doesn't really have a sign, and then +1. And C double prime is going to be -4, -1. So let's graph that and make sure it looks right. So -5, +4 puts us right here. That's A double prime. Then B double prime is at 0, 1. And then C double prime is at -4, -1. But if I look, that does look to be the correct reflection across this line for this shape. So let's end that video here, and then in the last video we will talk about line symmetry.